Hello and welcome to Season 2 of the ProtoPod, the podcast for engineers, innovators, entrepreneurs, and trailblazers shaping the future. I'm your host, Jordan Rose. Today on the ProtoPod, we're joined by Olivier Lamarre, a Ph.D. student at the University of Toronto STARS Laboratory, where he focuses on advancing planetary rover autonomy. Olivier has collaborated with NASA's Jet Propulsion Laboratory and co-founded the McGill Robotics Mars rover team, leading them to multiple podium finishes at the international competitions. This month, he is joining our friends at NordSpace as a systems engineer. Now let's get into the episode. Hey Olivier, welcome into the podcast. Super excited to have you on today. PhD student at the STARS Laboratory at U of T in Toronto, Canada, focusing on planetary rover autonomy, a topic we've covered quite extensively on the podcast, so excited to learn more.
Awesome. Glad to be here. Thank you for having me.
Yeah, absolutely. Can you just, start by telling me about your research at the STARS Lab? What it is that you're working on, and I guess what's most exciting to you?
For sure. So I'm currently a last year PhD student at the STARS Lab at the University of Toronto. And my research is focused on trying to improve the autonomy of planetary rovers, mostly in terms of their capability to adapt. So right now, I don't know, I'm hoping that most of your audience is familiar with, planetary rovers. There's a couple of them on the moon. The most popular ones, I would say, are the ones that have been roving Mars for the past 2 decades, roughly 2-3 decades. On a daily basis, these rovers essentially, or almost on a daily basis, still receive commands and help from human experts, human operators back on Earth, primarily from California at JPL. And that's primarily because these rovers have some autonomy, but it's very limited. And one of the key roles that humans fill in keeping the mission going is making sure that these rovers stay safe. There's plenty of hazards in the space environment on planetary surfaces, and the robots can identify very geometric obstacles, like anything that's related to geometry, like big boulders, craters, stuff like that. But there's plenty of other hazards. You can have a perfectly flat terrain, but it might be very loose ground. You don't want a rover to drive in there because it might stay embedded there. You might have very, terrain with very sharp rocks and stuff like that. One of the things that humans are very good at is adapting to local observations. So whenever something happens, say the rover gets stuck on a particular type of terrain that they were not expecting, they'll make sure to remind themselves to avoid that type of terrain in the future. So there's this ability to learn from past experiences along the way and keeping the rover safe and keeping them going with their mission. So that's more or less where we're trying to do with my research, or at least scratch the surface of this adaptive decision making with planetary rovers and try to get algorithms to start being able to do that and try to fill in the role of human operators this way. And it has huge implications down the line. Yeah,
so that makes a whole lot of sense. So it's really about applying machine learning to this application in order, I guess, to increase scalability of the rovers and rely less on those super smart folks at JPL operating them. I can imagine that, being that it's extraplanetary, that there's a lot of technical challenges with the that project and trying to implement said algorithms. Can you kind of walk us through some of the innovation and some of the really technically challenging problems you've had to work through during your PhD?
For sure. So I worked on projects that are in the context of both Martian navigation and lunar navigation. I guess I could talk about these two different groups of projects. The one on Mars is very much what I was talking about. So we have a robot. We simulate a robot trying to navigate a simulated Martian terrain. You can have there's plenty of global Martian maps available out there, thanks to all the orbiters orbiting Mars, right? Imagery from HiRISE and other orbiters and sensors. And you can simulate basically Martian environments pretty well. And in our case, what we were doing is we were giving the rover basically a network of different routes that it could follow to get from point A to point B. And point B can be located a couple kilometers away. And along the way, the rover would basically observe, or we would basically inject difficulties along the way on different types of terrain, and seeing if the rover could adapt to a specific, like, if it would encounter terrain with a specific tilt and a certain density of rocks on the surface. In our case, we would simulate failures of the autonomy software, and that would mean that humans in practice would have to take over and manually drive the rover through that specific type of terrain, which is very slow, and you don't want to do that. So we were trying to basically simulate this ability to learn from past experiences. The other line of work was more related to lunar mobility. So there's a lot of interest right now in exploring the lunar South Pole. And just like at the Earth's poles, when you're standing there on the surface, the sun remains very low on the horizon. And because of this very low sun on the horizon, the illumination conditions change dramatically over time. And on top of that, on the moon, there's a lot of craters, right? And at the bottom of the craters, the bottom of some of these craters are shielded from sunlight. And we think that there might be volatiles down there, CO2 ice, water ice, most importantly for future crewed missions and extract those resources there. But right now, people are interested in just, there's been detection of these volatiles from basically orbit observation. So you have satellites orbiting the moon, detecting the presence of these volatiles, but we're not too sure exactly how they're distributed, if they're easy to access. So right now there's a lot of interest in sending robots in these permanently shadowed regions, these PSRs, to start prospecting and mapping these different environments. And in our case, the challenge was, well, if we have a solar-powered rover driving in these environments, and you want the rover to basically dive into those PSRs, once in a while it has to make it out of the PSR to recharge its batteries, right, to expose itself to the sunlight. But because the illumination conditions change so dramatically, you really have to pay attention to how you plan your navigation. If something happens and then you're delayed by a couple hours, you might miss the sunlight when you leave the PSR. So we were tackling this challenge of how we design what it means to be safe at the lunar South Pole when you explore PSRs with a solar-powered rover, and how you can basically come up with navigations plans that are safe. If something was to happen, you have a fallback plan to exit the PSR maybe somewhere else where there'll still be sunlight, even if you're delayed. So that's the kind of problems we're looking at.
Very interesting. And obviously, again, given the remoteness, as you mentioned, there's lots of data that you can use to simulate these types of environments in a lab or what have you. I'm just wondering, though, if you found, given that these are difficult challenges, any particular project development or, methodologies that you might have found are really useful for you in solving those in a way that allows you to not get, bogged down by the challenge of the work. Like, how do you power through those experiments?
So essentially, you mean from my side, or more the technical innovations that we came up with?
I think from your side, what are you, how are you planning things in order to, to make sure that the question that you're trying to answer, how do we plan more effectively? How do we maneuver around this type of terrain? How do you do that in a way that allows you to maintain momentum on the project and accomplish your goal?
Yeah, so that's a very good question. Essentially, first of all, I'm very well surrounded. So at the University of Toronto, we have a lot of resources. I have a supervisor, Professor Jonathan Kelly, who's very supportive, so we can bounce off ideas whenever I'm stuck. So I have that line of resource. Also, I was lucky enough to work, or at least do a lot of research visits at JPL, the NASA Jet Propulsion Laboratory, and I'm still connected with these folks there. And these people there gave me so many pointers as to, hey, from our experiences, we've seen that that's a difficulty. Oh no, from our experiences, we've seen that's not really a challenge. Don't really work on that. But hey, you're stuck on this? How about try that? So I would also bounce off ideas with these people in California. And they've been so very generous of their time, still connected with them, still collaborating with them once in a while. So I've received also a lot of help from them. It's not just me. It's a big team effort.
Yeah, that makes a whole lot of sense. I mean, one thing that we chat about on the show quite often is this idea of moving things at velocity, and when project momentum is lost, how things kind of go into a black hole, to use a a space term. And that, really one of the best things that you can do is to ask for help. Internally, we kind of put a 1 hour limit on somebody being stuck on a problem before they have to go and ask somebody. Because your unknown or your uncertainty may be a known to somebody else, which it sounds like it was to some of the folks at JPL, which allows you to move forward. I wanted to kind of pivot. I know that obviously you have a really interesting and impactful Ph.D. That you're working on, but I know that in your past you also helped found Mars Rover Society. Can you talk to me about what the process of doing that was and what sort of satisfaction you got out of doing that?
For sure. So I've always been passionate about space, and especially planetary navigation. I'm not sure why specifically planetary rovers, maybe because they're an extension of human beings, like what humans would do if they were on the surface of another planet or surface of the moon. They would just rove around and explore, and that's what rovers do. So in a way, rovers are extensions of humans up there. But when I was at McGill University, I joined this team called McGill Robotics. And McGill Robotics was one of the engineering design teams. And when I joined, they were, right before joining, actually, they were working on, or at least participating in the NASA I think it was called Lunabotics competition. It was a competition down in Florida about space mining, especially like mining on the lunar surface. And when I joined, unfortunately, they pivoted away to another competition. Basically, they were designing an autonomous underwater vehicle. And I've got a lot of experience from working on that specific project for a whole year. And then when the next year came, they were open to starting another project inside of the team. And I pitched, hey, there's this University Rover Challenge competition taking place in Utah. I love planetary rovers. Most of you guys were building rovers even before that I joined. How about we go back to building rovers? And get that off the ground. And then they asked me, well, do you want to be in charge of it? Oh, yeah, for sure. I'll give it a try. So this was back in 2014, dating myself a little bit, 11 years ago already. I reached out to a few of the people who I worked with on the autonomous underwater vehicle project the year prior, people who I knew might be able to, they had this sense of taking initiatives and this ability, this easiness with people who I think would be good folks to be part of the core team of the planetary rover project, of the Mars rover project, essentially. And from there, we made it official, started the project. When the school year started in September, we opened up we created the form to let people enroll for those who were interested, and boom, the team blew up to 50, being more than 50 people.
Wow.
And we kept that momentum going for the whole 3 years that I was there, and they're still going to this day, I'm pretty sure. So I've seen a couple of their updates now at the Canadian Rover competition as well. So it's still going, but yeah.
Cool. I've had the pleasure to attend the URSV competition, and it's amazing what a group of students are able to accomplish, in a fairly short turnover time. And I'm wondering, you kind of alluded to some things, selecting a certain group of people who had shown some sort of initiative. Again, internally we like to talk about that as tenacity versus flexibility, and they're tenacious and they want to get something done, but creative and flexible in how they get there. I'm wondering, with a project like that, where it is, again, short turnaround times, a lot of subsystems that have to be built. What did you learn in the process of leading that team that you were able to carry it forward with you in your PhD?
Yeah, there's a lot of mistakes that we made and a lot of things we learned the hard way. I would say the very first one is we didn't put too much attention on, or we didn't put enough emphasis on testing. Testing is something you always run out of time for testing. You never complete a test campaign. There's always more testing you could do. On our very first year, we grew up to being a very large team very quickly, and we had to focus and manage all these efforts to build all these different systems on the rover, like the drive system, the manipulation arm, all the sensing, all the software, all the electronics, and we're very ambitious. And we went for a design that was pretty complicated, It was really good looking though. Like, the aesthetics was not what we were lacking. So it was really good looking, but it took a long time to execute and build. And on this first year, by the time that we made it, right before going to competition, we had tested a little bit the rover, but not enough. And we ran into this issue where we shorted all of our electrical system, I think 2 weeks before competition. So we showed up at competition with a not very functional rover, and we tried like really hard to make it working again. And so the first year was like we didn't perform very well, but no one on the team gave up. It was great, even though it was very unfortunate, the situation, but seeing everyone just keep pushing, that was awesome. And but no, testing, I would say testing is the biggest lesson that we learned for the follow-on years, like a lot of testing. Another lesson that I've learned is basically everyone can have agency in the team. And from a leadership perspective, I was at the head of the team technically, but ultimately when you're at the head of a team, you're a leader on paper, but leading a team is a lot of listening, not telling. And because it's a design team, no one is remunerated. There's no salaries. There's nothing like that. There's no like financial compensation. People are there to learn, and it's your responsibility as a leader to give a reason for these people to come back and keep working on the project. People are there to learn. People are there to contribute, and you want to encourage these people to take initiatives. You want to show them, hey, like everyone can be a leader. You can lead by example. You show up to the team for a work session, there's a task that no one wants to do, just take the initiative, just suggest, just volunteer, just be that person, Someone needs help, just volunteer to help them. Just try to take initiative, try to get ahead of the design process. Don't wait for someone to ask you to do something. If you see where the project is going and then something will have to be done, you have some time, all right, go ahead and do it. And these encouraging people to lead by example like that is something that people, first of all, love because it gives them a lot of freedom in what they're doing and it shows them that you trust them. And in the end, it returns to the team. Like the team is becoming much more productive. People collaborate way better together. People have a vision for what's going on because they joined the team, and then through discussion, they share your vision for the team. So it's a great thing. So yeah, giving people a lot more agency, encouraging them to lead is also something that I'll keep doing.
I think that's a really great perspective, and the enablement of that in others. But that idea of servant leadership, in that your job as a leader is, yes, to align your group on what your goal is, and to motivate them to get there, but also to serve them, in any way that you can, and inspiring others to do so. Spreads that messaging at every level, because at the end of the day, with a group of 58 people or whatever it was, it's very difficult to do that for everybody, but if you inspire people to do the same, it becomes a lot easier. You also said something interesting in there about testing, again, a commonality. And it's interesting, we talk a lot about this idea of project velocity, and that the faster you get things done, you don't lose momentum, as I mentioned before. But the idea that projects happen in these threads, and the end of a thread is really when something can get tested. And the faster you can get to that thread, and if that means duct taping a solution together or what have you to test it, the more successful you end up being, because you can find those little gotchas that you didn't know existed. So it's interesting to see this pop up, and I know obviously, like in a student competition where it's not their full-time job, they're doing this on a volunteer basis, that time is limited, and that becomes even more important. I'm wondering, on that front, you had mentioned how you've taken away a lot of leadership characteristics and principles from your time as a leader on that team. I wonder if you could speak to, maybe for yourself and for the others that you worked with on that, like how important the hands-on aspects of doing a project like that when you're an engineering student are, because I know that that's something that, depending on the institution, there's more or less of, but it's not a massive focus, or not as big of a focus as I think it probably should be.
For sure. Yeah, absolutely. I was a student at McGill University in Canada. And as much as I love McGill, their engineering curriculum is a bit less hands-on than many other universities, and I think it should be more of it. So just right off the bat, being hands-on with a project like that was making a huge difference between folks graduating from McGill without engineering design team experience and people with experience. And it got to a point where, there were situations where people were, final year undergraduate would show up to the team, and basic things like, using screwdrivers or hammers, and they're mechanical engineers, they would struggle with this too. And this is not a judgment at all. Like, they're on the team to learn and everything, but this was a big, being part of the team for so long, since my first year undergrad, and then seeing this fourth year people, not being able to work with basic tools like that was very telling. So that's extremely, extremely important. And ultimately, what people end up doing is, once you have a team, at least ours, that's in our case, people were very much encouraged to take initiatives and try to lead their own way. People will end up doing a bunch of tasks that they never initially signed up doing, from coordinating with sponsors, like all the business sides of things. Sometimes you'll have mechanical folks who will end up doing a lot of electrical stuff. You'll have there was also a science component to the competition. You'll end up having engineers work, or engineering students doing the science work, and then some science students ended up doing engineering work. There's a lot of multidisciplinary work going on. And when you enter the workforce, you realize that there's also a lot of that going on. So being part of an engineering design team in that sense feels like almost like a cheat code, because once the industry, and I remember in 2013, 2014, there was not as much recognition for engineering team experience, but now I think there's a lot of recognition for that in the industry. And people are aware now that what the engineering students in these engineering design teams went through is very much representative of what it's like to work in the industry. So I think this is an amazing way to, increase your skills, whether it's management, technical, just working on the project and working with other people over long periods of time, not just planning the project, but carrying it to term, working on the hardware, building the hardware, essentially dealing with your own design decisions. Sometimes you wish you made different design decisions, but you're like, hey, the project has to move on. That's what we've decided to do. And we'll continue working with those decisions because there's a competition coming up in 2 months. It really forces you to go through the whole life cycle of a project. And that is something that you just cannot have in classrooms. It pretty much is what you end up doing in industry. So
I think that's
add to your portfolio.
Yeah, I think it's incredibly well said. I can't add too much to that other than that I agree entirely. As somebody who graduated in 2016, and they definitely weren't as prevalent at that time, and I have seen that grow, and I think you've said it so well, and the emphasis right now in a lot of institutions that is highly theoretical and narrow, not multidisciplinary, I think sets a lot of people up for failure. And the benefit that you get is the real life. Hey, this is what happens when you actually do a project, when you're working with different teams, and you can apply that directly to your workplace when you enter it. It's less about every single heat transfer cycle, taking 4 thermodynamics courses. That's really not important. You can Google that. It's more about how you work through problems and being comfortable with doing that.
Yeah, and another thing I'll just add to that real quick is typically in classrooms, and I don't know of a better system, so I think we have a good educational system, but it could be improved. But typically in classrooms, when you work on homework, on team projects, there's usually a good answer to a problem. You do your homework, you do exams, there's one good answer, and you're trying to get to that one good answer. And when you start working on real life projects, it is very rarely the case. There's always trade-offs to be made, and you just need to basically be able to explain your design decisions, explore the trade space and make an informed decision based on that. There will never be a perfect decision, I think, in engineering, always trade-offs. And that's not something that I learned in classrooms.
Yeah, I agree again wholeheartedly. I've seen that a lot, and again, as me coming out of school, I know that I was more like that than I am now. There's an expectation from young engineers that X plus Y always equals Z. That there's it's totally deterministic, and that there's always one answer, and it's quite simply not. So again, I think it's an excellent point. So we've talked a lot about your past, what you're currently doing. I know that you have an exciting new position with one of the most innovative companies in our country. Do you want to talk to us about that and what you're excited for?
Yeah, I'll mention a couple things, but just very few things. But I cannot specifically talk about what I'll be working on. That'll be unveiled in a few months. But essentially, I'll be joining NordSpace. I think what's publicly known right now is that they have two big lines of work. There's the rocket launch business they're trying to pierce through, and simultaneously they're trying to push on the satellite front, the spacecraft front. I'll be helping them a lot more with this on the spacecraft front, but it's such a small company still that I'll probably end up helping with the rocket, on once in a while. But the folks at NordSpace are extremely innovative, extremely skilled, also incredibly kind and humble as well. They're people you want to have around. They're people who just have this enormous drive, and they're on the launch pad today. They're trying to get their first suborbital flight, their first suborbital rocket off the ground, which is amazing. And I don't know if you guys had the chance to talk with their CEO, Rahul Goel. I think he'd make an amazing guest on this podcast.
He was. I think if not our first guest, one of our first guests. Yeah.
Oh, really? There you go. Okay,
amazing.
Okay.
Yeah, we've been following the journey. I should have
done my homework better.
No, it's all good. We just give you something to listen to now. We've been at ProtoSpace, the whole family of companies. We're tracking the progression of the launch very closely. We've had the live streams going every time they've been on. So super excited to see what happens. I know that it'll all work out. A lot of variables there, weather, all that sort of stuff. So I know that.
Yeah, and I think this morning there was just a boat that ventured into the not the no-fly zone, but the no-boat zone. Which is these are the variables you have to deal with. But what I'll be working on is, again, it's the same line. It's in the DNA of NordSpace. They just want to push through, innovate, and I'll be working on a very innovative project for Canada, I think. It'll be super impactful, super exciting, and we'll unveil that in just a couple months. But I'm not going to say anything more than that.
That's totally okay.
I'm so excited. I wish I could tell you, but we're going to keep it. Just hold the suspense a bit longer for a couple months.
We'll be eagerly anticipating, and hopefully maybe we can get you and Rahul to join us again, maybe in a group setting, and we'll recap what you guys are cooking up, because I agree it's one of the most innovative companies in Canada, and one that we're following closely. So I wanted to end with our rapid fire segment.
Sure.
So the objective here is to answer these quirky little questions as quickly as possible. So you ready?
Yep.
Cool. So the first one, Moon or Mars?
I'll have to say Mars. Mars is further. You got to explore. Got to push the frontier. Mars.
Rocket or rover?
I'll have to go with rovers.
Yeah, you're biased there.
Yeah,
silly question.
I know I'm joining NordSpace, but I'll have to go with rovers.
Yes, yeah. Coffee or tea? Low ball.
Coffee.
Coffee. Yeah.
Yeah.
Early bird or night owl?
Early bird.
Early bird. Favorite tool, gadget, or piece of tech that you use?
I wouldn't say it's something that I use on a daily basis, but there's a very cool sensor that we used for our dataset collection at the Canadian Space Agency when I first started as a grad student. It's an omnidirectional stereo camera. So, real quick, I don't know if, you guys are probably familiar with the Insta360 cameras, like the omnidirectional cameras.
Yes, yep.
Look at these feeds. They don't, you have a panoramic view of your surroundings, but you don't have depth perception. And so we had this camera that it was a big module with 5 cameras looking in 5 different directions, and an exact replica of this module right below it. So you could pair up cameras vertically with one each other. So the cameras could do stereo matching. So on top of having a panoramic field of view, you also had a panoramic point cloud and 3D model around the robot. And I think I might have it here, real quick. Yeah, I'll just show that to you.
Just hiding under the desk.
Yeah, it's one of those sensors here, but see, so it's one of those
Cool.
cameras. So basically, you have cameras all around, and then the ones on the top and the bottom correspond with each other. You can do stereo matching.
Two
and
eyes.
build 3D models. Yep, essentially 2 eyes.
Very cool. One engineering principle you live by.
Probably simplify. Simplify. Not just your designs. Typically, a simpler design is better. But also just simplify your explanations and how you describe it. In academia, there's this clear trend where papers whose authors took the time to explain the concepts in much simpler and accessible terms have a much bigger impact on the field than others that sound very complicated. So I would go with just simplify.
I love that. Worst learning from failure moment you've had?
Probably our first year participating at the University Rover Challenge. We had this, I mentioned earlier, we had this big electrical short. The electrical people never gave up, but ultimately a lot of them ended up leaving the team after the first year because they were just burnt out. They gave 1,000% of what they had. And this was a mistake I made well before this. We agreed to just commit to something that was extremely ambitious. As a leader, I should have just pumped the brakes a little bit and focused more on testing and encourage simpler designs. And that's one of the learning experiences. I think it's one of the biggest ones.
I think that's very insightful. I think that's very good. If you could instantly solve one challenge in your field, what would it be?
I think the easy answer would be adaptive decision making, my field of research. If you could have robots that you could just send anywhere in the solar system, and then they would be able to learn from their experiences and carry on their mission, it would be huge. Not just because you wouldn't need a whole team of human operators to control robots like what we're doing now on the moon or Mars, but then you can start exploring worlds that are so much further away in the solar system. The ocean worlds around Jupiter and Saturn, the moons around Uranus and Neptune. There's so many worlds out there that are just way too far for us to control. Basically, if we were to send a robot there, we wouldn't be able to control them in the same way that we're controlling rovers on the moon or Mars right now.
That's due to the delay in communications?
Primarily, yeah, so delay in communications. And just to give you an idea, in the worst case, when Mars and the Earth are the furthest away from each other, round-trip communication will probably take around 20, 25 minutes. That's in the worst case. If you were to send a probe on, I think it's Triton, one of the moons around Neptune, the best case scenario is 8 hours round trip. That's the best case scenario. So you can no longer control these robots, send them commands every day. You have to let them be autonomous and carry out their mission, and just need to communicate with them once in a while.
Yeah, I think it's an incredible field, and I can't wait to track that as it continues to get innovated on. And I do think, as you mentioned, the applications are really without this. It's totally not feasible to take on those missions. So excited to see where that goes. Olivier, thank you so much for your time, and I'm going to have to hold you to that the visit with Raul once the NDA is lifted.
For sure, yeah. Anytime, call us anytime, and once this project takes off and we unveil it, we'll be more than happy to talk a bit more about that with you guys. But thank you so much for having me on today. It was a blast talking to you.
You're more than welcome. Until next time, bye-bye.